Hi, my name is Stacey Archfield, and I'm a research hydrologist with the USGS Water Resources Mission Area. I'm also the project manager for the National Streamflow Drought Prediction Project. And I'm really looking forward to hearing your feedback today on how we can prioritize the research that we're doing in this project to serve you, the stakeholders of our research. I just want to take a moment to acknowledge our project staff here, show their faces and their names as well. So when we were developing this project, the first thing we really wanted to do was think about what the properties of a national drought prediction system would look like, and use those properties to then drive the research questions that we would ask in the project. And so I'm going to show you a set of boxes of what we thought the main properties of this national drought prediction system are. And of course, throughout the listening sessions, we would ask for your feedback if you feel like we are missing something here or you want to add additional properties that you feel we need to have in this national drought prediction system. But the first box we have I'm showing is accurate, timely, and locally relevant drought predictions is a property that the national drought prediction system should have. Another would be long-term prediction of extreme conditions for different components of water availability. Now, I know the focus of today is on stream flow, but of course we want to account for different components of water availability like groundwater, soil moisture, and other particular aspects of water availability. We also want the capability not just to predict particular drought metrics, but we also want to be able to convey drought risk. So the probability of a particular metric entering into drought would be something that we may want to convey for different components of water availability as well, including ecological flows. And the last piece is that we want these predictions of conditions, these drought metrics, the condition of the drought metrics, and then the risks, the potential of going into a particular threshold, exceeding or a particular threshold of a drought metric to include the effects of human activities, not just a natural condition. And so now this is where we talk about, using the questions to kind of drive your end user input to drive and prioritize the research. So I've placed kind of the properties of this National Drought Research Project here on the right, and then we can think about the types of questions we would need to answer in order to get at the end product, which is this National Drought Prediction System. And so we can think first about what it would take, what questions we would need to answer to get at accurate, timely, and locally relevant drought predictions. And those might be, what are the most informative and or actionable drought metrics to predict? What is the achievable level of accuracy for drought predictions? What is the spatial scale at which these predictions are needed? And how often should these predictions be updated? And then to get at long-term prediction of extreme conditions for different components of water availability, we might ask, well, what is the forecast horizon for each drought metric? And perhaps that forecast horizon might be different for, say, groundwater versus a surface water metric. And then in terms of the capability to predict drought risk for different components of water availability, we might ask, what could be conveyed about risk of entering a drought? What are the types of risk information we need? What are the thresholds that are most important? And what other risk information might be useful? And then lastly, for predictions, we need that to include both natural and human effects of drought. We need to understand what are the most important effects to consider and how does the relative importance of these effects differ nationally? Certainly that we could think about different parts of the United States having different effects, different relative effects being important on drought. And we need to account for that in our national prediction system. So now we look at what the current drought research is going on right now in support of prediction. So there's many questions to be answered. This is what we need help with in terms of prioritizing this research. Many questions to be answered, and we can only look at a handful of them at any given time. So right now, the orange boxes of the brown boxes I just showed you, those are the ones that we're addressing right now. But we're certainly open to reprioritizing our work or listening to how we might be able to even adjust the work in the orange boxes. That's what the purpose of these listening sessions are. And so I'll just go through some of the work that we are doing with respect to that. So first, we're building core data sets of USGS stream gauges and groundwater networks, as well as remotely sensed data sets to be used for analysis and prediction. And this isn't just, putting data sets together of data we have already available, like online for you to download, but this is also looking at what are the factors that affect the stream gauges and groundwater networks, things like land use or reservoirs that might be within the area that's contained within the contributing area to those wells or to those stream gauges. We're also looking at the identification of major drought events using those metrics that we identify for these different aspects of water availability, also including paleo droughts. We're testing machine learning approaches to predict drought and then to predict those drought metrics. We're also examining drought with respect to frequency, occurrence, magnitude, and onset and recovery. We're characterizing the trends and variability in drought events and changes to the timing of drought events. And then we're also working collaboratively with our federal and academic partners and leveraging the existing data sets that they might have that we may not have in-house at the USGS. We're also working to link hydrologic drought to other phenomena, including wildfire, floods, snow drought, water quality, and flash drought. So with all of that, I hope I've given you some things to think about for the breakout sessions. Some of these questions will be asked directly in the breakout session, and we look forward to your feedback on this and your help. So thank you so much.